On behalf of the USDA Natural Resources Conservation Service, the Georgia Soil and Water Conservation Commission, the Upper Chattahoochee River Soil and Water Conservation District, and Schnabel Engineering, we thank you for your interest and participation in this third public meeting for the Supplemental Watershed Plan and Environmental Assessment for Settingdown Creek Dam number 54. The purpose of this planning study is to assess the Settingdown Creek Dam 54 watershed, as well as evaluate the performance of the existing watershed structure. The planning study will develop a plan to address any identified compliance issues with the dam and determine if federal financial assistance will be available to address those issues. Also, the planning study will result in the determination of whether or not the project sponsors would like to continue operation of the dam within the NRCS watershed program. Public participation is of great importance to the planning process. The objective of our public participation plan is to inform you and other watershed stakeholders of the planning effort. A series of public meetings are required. The first and second public meetings included a brief history of the NRCS watershed program, a brief history of dam safety, considerations for dam design, operation, and maintenance, an overview of the Settingdown Creek watershed and the dams that are included in this planning study, and also concluded with an opportunity for the solicitation of questions and comments regarding scoping topics and project opportunities and concerns. The second public meeting included the presentation of a list of potential rehabilitation alternatives for the dam. The first public meeting was posted to Schnabel's YouTube channel from August the 7th until August the 17th, 2020, and the second public meeting was available from December the 18th until January the 4th, 2021. Please note that the first and second public meeting presentations have been reposted to Schnabel's YouTube channel for those interested in viewing the presentations and the content described above. During this third presentation, we will provide a review of the Settingdown Creek watershed and the specific dams included in the planning study. We'll also talk about the existing conditions associated with the dam and present 3 shortlisted alternatives for addressing concerns with the dam. At the end of this presentation, there will be an opportunity to submit questions and comments for the planning team's review and consideration. The Settingdown Creek watershed is located in northern Forsyth County, Georgia. The creek is a tributary of the Etowah River, which flows into the Coosa River near Rome, Georgia. The watershed contains over 34,000 acres of drainage, and the original watershed work plan, which was prepared in the early 1950s, provided for the construction of 15 floodwater retarding structures known as the Settingdown Creek dams. This slide presents a delineation of the Settingdown Creek watershed beginning at its confluence with the Etowah River at the left or west side of this map. As you can see, the watershed is delineated in red, and the locations of several highways in northern Forsyth County, Georgia are indicated for reference. This slide presents a delineation of the watershed overlain on aerial photography from the early 1960s, which would have been taken shortly after the construction of most, if not all, of the Settingdown Creek dams. As you can see, there have been some changes to the land uses in northern Forsyth County within the watershed since the original construction of the dams. As part of the supplemental watershed planning study, several focal points of analysis and study are involved. We, the planning team, considered upstream areas that are subject to flooding, as well as the need for the potentially needing additional storage upstream of the dams. We also looked at downstream areas with regard to storm flooding, as well as hypothetical breaches of the dam and the areas that would be impacted as a result. The hydraulic capacity of the existing spillway outlet works was assessed and evaluated for several different storm events. Additionally, economic and social benefits associated with the project were considered, along with an assessment of environmental and cultural resources in the project's vicinity. Here's a map of the watershed again, with the locations of several dams that are being studied at the same time. You'll note that several of the dams in the study, the upstream 5, are located on the east side or right side of this view, and Settingdown 27, which is also being studied as part of this package of dams, is located at the downstream end of the watershed. With regard to Settingdown Creek 54, which is the subject of this presentation, the dam meets Georgia Safe Dams Program criteria to be considered a Category 1 or high hazard potential dam. This means that failure or improper operation of the dam would likely result in the loss of human life. The dam requires an operating permit from the Safe Dams Program. Previous assessments of the dam indicated that the dam does not comply with current SDP rules and requirements. The dam is not exempt from these rules, and the purpose of the planning study is to determine if federal assistance will be available to bring the dam into compliance with current safety requirements. The Georgia Safe Dams Program is fully aware of this dam, its classification as a high hazard dam, and that the dam is being studied by the planning team. Original design features for Settingdown 54 include that the dam was not originally designed as a high hazard dam. Development downstream of the dam has occurred since its original construction, increasing the hazard classification from low or significant to high hazard. The purpose of the dam is flood mitigation, with a secondary purpose of sediment accumulation and storage. The principal spillway system for the dam is comprised of a reinforced concrete riser structure and nearly horizontal pipe or conduit that conveys flows from the lake through the dam to the outlet channel at the downstream toe of the dam. There's also a vegetated earthen auxiliary or emergency spillway located adjacent to the dam to convey flows associated with low frequency, high intensity storm events. Once again, here's a map of the Settingdown Creek watershed. The location of Settingdown Creek Dam number 54 is highlighted in yellow. You'll note that it's near the northeast side of the watershed in this view. The dam is located north of the intersection of Dahlonega Highway, Highway 9, and Burris Road. The dam was constructed in 1954 and appears on the National Inventory of Dams. It has a surveyed height of approximately 27 feet and a drainage area on the order of 2.5 square miles. The total storage capacity that the dam was designed to have is 697 acre-feet. That includes sediment storage, flood storage, and surcharge flooding storage above the auxiliary spillway control section. This slide presents an aerial photo from the 1950s, which would have been taken shortly after the completion of the dam. You'll note the location of the dam and the areas surrounding it, and We'll fast forward to an aerial photo taken more recently and note that some development has occurred both upstream and downstream of the dam since its original construction. A limited topographic survey of the dam was performed to support planning efforts. This slide depicts that survey, which is overlain on an aerial photo that was taken after the dam was recently cleared this past summer. You'll note that several survey shots are indicated on this view. I'll point out the location of the principal spillway riser structure. It is the light gray square located at the top and left edge of the lake. The auxiliary spillway channel, the vegetated spillway, is located to the left of the lake in this view and generally runs in a bottom to top direction from this view. You'll also notice that the dam has been cleared and the lake is at the bottom of this view. Here's a topographic map of the dam site. Once again, the locations of the principal spillway riser and conduit are indicated near the left end of the dam. The center line of the auxiliary spillway is indicated. It's a relatively narrow auxiliary spillway for this structure. You'll also note the location of wetlands that were delineated as part of the environmental survey work performed for this dam. Also of note, there is a existing sanitary sewer line that runs immediately to the right of the dam in this view and then turns down into the floodplain and runs relatively parallel to the outlet channel for the dam. Here's a photograph of the dam taken from the upstream slope. The riser structure for this dam is generally tucked into the upstream slope of the dam. You'll see the lake obviously to the right of the riser structure. The upstream slope is in this view, as well as the crest or top of the dam. This photograph was taken from the crest of the dam near the left end, viewed in the downstream direction. The downstream slope is in the foreground of the photograph. The principal spillway conduit, the concrete pipe, is indicated, along with the plunge pool where flows from the riser structure are conveyed via the conduit. An environmental survey was performed to support the planning efforts for this dam. An aquatic resource survey exhibit is shown on the left side of this view. The area of survey is indicated by the red boundary on this view, and the locations of streams, wetlands, and open water are also indicated. Some invasive species, predominantly Chinese privet, were identified in the upper reaches of the watershed for this dam. The environmental survey resulted in the finding of no protected species in the vicinity of this dam. Additionally, a phase 1 cultural resources survey was performed for the dam. The survey map at the left shows the location of survey transects and shovel tests that were performed. A literature review for the dam was also conducted. No archaeological resources were recorded as a result of the survey. The dam, being greater than 50 years old, is technically eligible for the National Registry of Historic Places. However, the Cultural Resources team does not recommend placement of the dam on the registry. No additional cultural resources work is recommended for this dam. As part of an evaluation of the downstream areas below the dam, a hypothetical dam breach was performed and modeled. This map shows the limits of inundation associated with a hypothetical sunny day failure of the dam, along with the location of structures that would be potentially impacted were the dam to fail in a catastrophic manner. Note that the location of the dam on this map is at the upper right view, and flows from the dam breach would progress in a right to left direction. The sunny day breach limits are shown in blue. In addition to the dam breach analysis, the planning team assessed the downstream areas during the 2 through 100-year storm events. The model for this flood analysis includes the other upper dams within the Settingdown Creek watershed, and those are indicated on this map. The location of inundation limits for the 100 and 500-year storm events are indicated in yellow and purple respectively, along with structures that would be potentially impacted or flooded during these storm events. A series of storms were routed through the lake and dam and spillway outlet works for Settingdown 54. This map indicates the upstream flood limits for the dam, along with key elevations for the normal pool, auxiliary spillway, control section, and dam crest. You'll note from this view that there are a few residences that are impacted by various events. Note that one structure, a residential outbuilding, is below the dam crest elevation. Also, portions of a detention pond are lower than the existing crest of dam elevation. There are also several homes around the limits of the upper limits of the flood levels that would be impacted during the NRCS design storm event for this dam, which is known as the freeboard hydrograph storm event. This event would equate to approximately 30 or 32 inches of rain over a 6-hour period. We'll review some of the existing deficiencies with this dam that have been identified as part of the planning study. As indicated previously, the dam was recently cleared about a year ago during the summer of 2020. Structural deficiencies with the outlet works include that the riser is embedded in the embankment and silt has accumulated, hindering access to underwater portions of the riser. This means that the existing gate is not accessible and is likely not functional. A closed circuit television inspection of the principal spillway conduit was performed, and the interior of the pipe after review appears to be in acceptable condition for continued use in its current state. Existing hydraulic deficiencies for the safe dams level storm event include that the dam overtops by almost a foot during the 1/3 probable maximum precipitation storm event, which is the SDP design storm for this dam. With regard to NRCS criteria, the auxiliary spillway engages during or prior to the principal spillway hydrograph storm event, which is an evaluating storm event for auxiliary spillways. The auxiliary spillway control section is too low and would need to be increased by 3.1 feet to meet NRCS requirements for earthen spillways. The dam overtops by over 4 feet during the NRCS design storm, which is 100% of the PMP, and the auxiliary spillway would fail or breach during the design storm. The planning team has shortlisted 3 alternatives to address concerns, deficiencies, or issues with the Settingdown Creek Dam number 54. The first alternative is a no action alternative, which simply means that federal investment would not be utilized to improve or upgrade the dam. The no action alternative would require that the dam meet criteria from the Safe Dams program at the state level for a high hazard dam. The no action alternative could be either the permanent breach of the dam or a rehabilitation of the dam to meet state criteria. The criteria for selecting whether or not a breach or rehabilitation is selected for the no action alternative is based on the total installation cost for the project. Removing the dam itself, the construction related to that may be less expensive than rehabilitating the dam, but also considerations have to be given to downstream areas and how to protect those against flooding that would become more apparent in the event that the dam were removed. A decommissioning alternative also is required to be considered as part of the planning process. This decommissioning would involve removal of the entire embankment, stabilization of the lake, and may also require flood proofing or relocation of downstream interests. The last alternative that we'll look at today is the future with federal investment alternative. This would allow the sponsor to access federal funding to rehabilitate the dam to NRCS standards. It would involve improvements in the embankment, the removal and replacement of the principal spillway riser structure, and improvements to the auxiliary spillway by decommissioning the existing spillway and likely constructing a structural spillway. During the development of the NRCS alternative, consideration was given to upstream non-flood control ponds, as well as uncertainties associated with climate change. So the no action alternative for this dam would involve the permanent breach of the dam. The planning team has studied this, and from a costs perspective and environmental perspective and economic perspective, removal of the dam in the no action alternative would be preferred over trying to rehabilitate the dam to meet Safe Dams program requirements. This breach would not involve a complete removal of the embankment, but only a portion of the embankment where the principal spillway is currently located. The resulting channel would be stabilized at the base with riprap, and portions of the excavation will be vegetated. The resulting lake bed would also be stabilized with permanent vegetation. Here is a site plan that indicates what the Safe Dams program level breach of the dam would entail. The breach would result in the permanent draining and loss of the lake were this alternative to be instituted. The existing principal spillway system would be removed, and the material excavated from the breach would likely be disposed of generally in the staging area located at the right side of the view here. And just to reiterate, no federal funding would be used for this activity. The decommissioning alternative would involve the complete removal of the dam and would need to be performed in accordance with NRCS requirements for dam decommissioning. It would also involve reconnection of the grades through the dam footprint to the original floodplain, stabilization of the lake bed, and stabilization of the primary channel through the footprint of the dam with riprap. This alternative would improve flooding benefits upstream of the dam, but the downstream flood benefits currently provided would be lessened or lost. The planning team has performed an economic analysis associated with the removal of the dam and has quantified the benefits that the dam currently provides, as well as the loss of those benefits if the dam were to be removed. Similar to the Safe Dams program breach, the decommissioning alternative would result in the permanent loss of the lake. But the entire embankment itself would need to be removed to comply with the NRCS requirements for a dam decommissioning. You can see that the principal spillway would also be removed in this alternative, and the resulting primary channel where flows would flow on a consistent or perennial basis would be lined with riprap to stabilize the footprint of the old dam. Here's a couple of photos with examples of removals of the dam and stabilization of the primary channel through the dam. You can see the riprap lining where the flows are consistent, and areas that are disturbed as a result of removal of the earthen embankment would be stabilized with permanent vegetation. The final alternative that we will discuss today is the future with federal investment. This alternative would allow the local sponsors to have access to federal funding to offset the costs associated with rehabilitating the dam to NRCS standards. This alternative would involve raising the crest of the dam to the current maximum water surface elevation associated with the design storm event, regrading the upstream and downstream slopes to 3:1, constructing a riprap-lined wave berm across the upstream shoreline of the dam, decommissioning the existing vegetated auxiliary spillway by placing compacted earth fill up to the proposed dam crest elevation, and addressing or relocating the existing sanitary sewer to the right and downstream of the dam as necessary to accommodate the rehabilitation efforts. A new principal spillway riser structure would be installed, and the existing spillway riser structure would be removed. Portions of the existing conduit would be reused, but extended in both the upstream and downstream directions to accommodate changes to the riser structure and the embankment. A riprap-lined plunge pool would be constructed at the downstream end of the conduit. The auxiliary spillway necessary to pass the NRCS design storm for this dam would be an OG crested roller compacted concrete stepped spillway. The spillway would have a crest width on the order of 435 feet wide and a step height of 1 foot. The spillway would be constructed over the majority of the existing embankment, and consideration would be given to providing access to both sides of the spillway from the dam crest, likely via a ramp on the upstream side of the spillway. The spillway includes a stilling basin and a riprap-lined apron to dissipate energy associated with high-flow storm events. Please note that this OG crested spillway would not flow on a regular basis. The riser structure for the lake and dam would establish the normal pool elevation of the lake at the current normal pool, and would convey flows for smaller storm events. The large auxiliary spillway would only flow for storm events in excess of the 100 and 500 year storm events. Here's a site plan with the proposed auxiliary spillway shown. As you can see, the spillway will need to take up the majority of the existing dam. This is due part to the size of the watershed, the land uses within the watershed, and the available storage of the lake. Those are the reasons why this spillway needs to be as large as it is. As you can see, we've overlain the spillway so that the existing sewer line is shown where it is. This sewer would likely need to be relocated slightly downstream to accommodate the footprint of the proposed spillway. The wave berm with riprap is indicated at the bottom side of the dam in this view, along with improvements to the principal spillway, including the construction of a new riser structure. The vegetated auxiliary spillway located at the left side would be filled in with embankment material and would become part of the new dam crest. Here's a profile view of the principal spillway and RCC step spillway. Due to the size of the auxiliary spillway needed, the proposed riser structure or the proposed principal spillway conduit will be designed to penetrate the RCC steps and discharge directly onto the downstream apron of the auxiliary spillway. The auxiliary spillway would also be designed and constructed with the OG crest to provide some level of efficiency and reduce the amount of straight weir length required for this particular spillway type. Included some photographs of examples of RCC step spillways that serve as auxiliary spillways. As you can see from this aerial photo, we're looking at the downstream face of the dam and RCC step spillway. In this case, the sidewalls of the spillway are constructed of reinforced concrete along with the headwall structure at the upstream end. The stilling basin for this particular spillway has been backfilled with soil and allowed to revegetate. Given that these spillways are only designed to engage during very low frequency, high intensity storm events, some owners prefer to cover the RCC spillways for aesthetic and maintenance reasons, and then grass can be established over these spillways in some cases. Here's another example. This spillway does have an OG crest and also involves placement of soil and grassing all the way up to the crest of the spillway. We've got another view from the side of this OG crested spillway, and you can see how access from one side of the dam to the other would be accomplished with this layout. And then here's one more example of a spillway where the principal spillway discharges into the stilling basin for the auxiliary spillway. You can see at the base of the step spillway, which has been covered with grass, with soil and grass, where the principal spillway pipe is discharging that small flow of water at the base of it. But this dam also features reinforced concrete sidewalls for the auxiliary spillway and a head wall system that allows for access from one side of the dam to the other. As a result of the planning effort, the planning team has had several meetings with the project sponsors and representatives of the NRCS, and a locally preferred alternative will be presented for this dam as the future with federal investment alternative. This alternative will allow the project sponsors to obtain federal funding to assist in the rehabilitation of this dam. As just stated, this alternative would involve the construction of a new principal spillway riser structure and improvements to the embankment, including raising the crest of the dam, and the construction of the RCC step spillway with OG crest over the embankment. As we stated at the beginning of the presentation, your participation and the participation of other project stakeholders is extremely important in the planning process. We invite you to submit questions and comments regarding the plan and the alternatives discussed and presented for consideration by the planning team. Questions, concerns, and comments may be submitted by accessing a Google form at the web address provided in this blue link. Please note that the link is not clickable in the YouTube recording. We will include the link in the comments section of the YouTube video. And if you're unable to access that link, the link can be typed in to a web search address bar such as Google, Chrome, or Internet Explorer. So if you need to take some time to write down this link so that you can submit questions, please feel free to pause the recording at any time to do so. The planning team will accept questions and comments for this third public meeting through Monday, July the 19th. Once again, we would like to thank you for your interest in this planning study and your participation in this third public meeting. We do encourage you to submit your questions and comments in a timely manner so that they can be properly considered and addressed. And we thank you for your time and your attention.